Welcome to our deep dive into the world of Sir Isaac Newton. We hear about the gravity apple all the time, but that doesn't even begin to cover all he did.
It's amazing, isn't it?
Yeah, we've got some amazing stuff to look at today. Excerpts from a biography with personal letters, and then some of Newton's own writings.
So we can see how he thought, not just what he discovered.
Exactly. That's what we're doing today, uncovering just how brilliant he was and what made him tick and how he saw the world.
Maybe even challenge some of the things we think we know about him.
Oh, yeah.
Like his childhood. He was born on Christmas Day in 1642.
Easy to remember.
But he was premature, and his father died before he was born. Makes you wonder how all that affected him.
Yeah. Like the universe was setting him up for a dramatic entrance, I guess. And his intelligence was obvious right away. The biography mentions how he was smarter than his tutor in a lot of subjects.
And he never stopped wanting to learn. Even regretted rushing through Euclid's work. I think that's kind of sweet. Shows how much he valued really knowing the basics.
But then he turns around and masters Descartes' analytical geometry. Like, it's nothing. How did his brain even work?
That's what's so interesting about Newton. He could just absorb information, but he always wanted to go deeper. And that's where his mathematical innovations come in. You know about the binomial theorem, right?
Yeah.
But it wasn't just some random formula. He revolutionized algebra, and it led to his work on calculus.
Calculus isn't really my thing. What made Newton's way so revolutionary?
Well, before Newton, mathematicians mostly looked at quantities that didn't change, like the area of a square or the length of a line. But the world is full of things that are always changing: planets, orbiting things, falling, even how water flows. Newton's calculus, with its concept of fluxions, gave us a way to understand and predict these systems.
So he wasn't just messing around with the numbers. He was explaining how the universe works.
Exactly. It was a huge step forward in figuring out how things behave, from planets to fluids.
I always pictured Newton hunched over his desk doing calculations. But then I read about his work in optics. It started with a real problem. Telescopes back then weren't very good.
Right. Blurry images, weird colors. They were limited.
And Newton, being Newton, wasn't happy with that. What was it actually like to look through one of those old telescopes?
Imagine trying to see the stars through like a blurry rainbow mess. That's what astronomers had to deal with. So Newton started playing around with prisms and light.
And that's when he made his huge discovery about what light actually is.
Exactly. By watching and analyzing, he found that white light isn't just one thing. It's made of different colors, each one bending differently when it passes through a prism. That's why lenses had those color fringes.
So prisms weren't just pretty, they helped us understand a basic mystery of the universe.
Exactly. And it changed optics forever. We finally understood light and color. It opened up so many possibilities for science and technology.
It's amazing how one person's curiosity can change how we see the world.
And that brings us to something else about Newton, how he worked. He was studious, persistent, detail-oriented. But he also had amazing intuition. Like, he could see connections others missed.
He actually gives advice on observation, discussion, and learning in his notes. It's like seeing inside his mind.
He said to question everything, test your assumptions, and always look for new perspectives. Good advice for anyone.
Speaking of observation, Newton's experiments with prisms weren't just looking. It was careful measurement. He isolated colors, measured angles, figured out their properties. He even did risky experiments on himself with sunlight and after images.
Don't try that at home.
Definitely not.
Yeah.
But it shows how dedicated he was to science. He was willing to push limits to learn, and those experiments led to his theory of fits, his model of how light interacts with surfaces. Like each experiment, each observation was another piece of a huge puzzle. And maybe the most famous piece is his book, Principia Mathematica.
The Principia. Even the story of how it got published is interesting. Edmund Halley, Halley's Comet, he was the one who encouraged Newton to write it and even paid for it to be published. Everyone was excited about this book.
So what were the main ideas that changed our understanding of the universe? Everyone knows about the apple and gravity, but was there more?
The apple falling is a good analogy, but the Principia was so much more. It laid out Newton's 3 laws of motion, and the biggest one, the law of universal gravitation. Those laws showed how objects move on Earth and in space. It's like he found the code that runs the universe.
The apple, the moon, the planets, all controlled by the same law.
Exactly. The universe wasn't random. It was a system with order and predictability.
It's amazing that even with all that science, Newton was also religious. It makes him seem more human.
Absolutely. He believed God was the ultimate cause behind the laws he discovered. The universe wasn't just a machine. It was designed by an intelligent creator. For Newton, science and faith weren't opposites. They helped each other explain the world.
This actually goes against the idea that Newton had a mental breakdown in the 1690s.
What we've read tells a different story. He was stressed, he didn't sleep well, maybe there was some emotional stuff, but he was still brilliant. He kept working. A breakdown just doesn't fit.
It shows that even geniuses have problems, and it makes his work even more impressive.
Absolutely. It makes his story more interesting. It shows how resilient people can be even when things are tough.
So we've covered Newton's early life, his work in math and optics, the Principia, and even debunked the breakdown myth. But we're just getting started, right?
You got it. There's so much more to Newton's life and work. Trust me, there's a lot more to uncover. Ready for more? Let's talk about how Newton used his theories to understand the solar system. It wasn't just equations for him. He actually showed how planets orbit the sun and moons orbit planets, all held together by gravity.
Okay, she had the laws, but how did he prove they worked in the real world?
He calculated take Jupiter and its moons. He measured their orbits, how long they took and how far away they were. And guess what? The ratio of those numbers matched perfectly with his predictions based on the laws of motion and gravity.
No arguing with that.
Right, but he didn't stop there. He figured out how heavy planets are and how dense they are. You can't exactly weigh a planet on a scale. So he looked at the tiny wobbles in their orbits caused by their gravity. From that, he could figure out their mass. And once he knew the mass, he could use the size to calculate the density.
So he's weighing planets from light years away, just from these little wobbles.
Amazing, right? And then there are the tides. Before Newton, people knew they happened, but nobody knew why. He showed that the moon's gravity is strong enough to pull the oceans and create those bulges we see as high tide.
So he explained things that people see all the time but didn't understand. That must have been pretty cool.
Absolutely. And remember, all this was in his book, Philosophiae Naturalis Principia Mathematica. It wasn't just discoveries, it was a whole new way to look at the universe. He defined things like time, space, motion, and force, and then built his arguments using geometry and those fluxions we talked about.
I'm starting to see why it's so famous. But it was also really complicated, right? He talked about some stuff that's still hard to understand today.
Oh, yeah. He got into things like how things fly through the air with resistance, like how wind affects a cannonball. He also studied fluids, pressure density, how waves move. It wasn't just about space. He was trying to understand the world here, too.
So he was connecting these big ideas to things we see every day.
Yeah.
No wonder his work was so important.
Exactly. And his curiosity was endless. Remember how we talked about his work with prisms and light? There's so much more to that.
Yeah, he didn't just prove that white light is made of colors, did he?
No way. He measured exactly how much each color bent, creating the basis for optics. He even had theories about light. We can't see what we now call infrared and ultraviolet. He knew the visible spectrum was just part of something bigger.
He was a visionary. And he even built a better telescope.
That's right. His reflecting telescope used mirrors instead of lenses, so no more color fringes. It was a huge improvement. Astronomers could see the universe more clearly.
So mathematician, physicist, optics expert, telescope designer, anything he didn't do.
Well, actually, that's a good question. We think of Newton and space and light, but his curiosity led him to all kinds of science.
Like what?
Remember how he loved studying how things change and move? That led him to fluids, water, air. You wouldn't picture him playing with water balloons, but he studied how fluids flow under different conditions. He used glass tubes and containers to look at viscosity.
Viscosity, like how honey is thicker than water.
Perfect example. And Newton made a mathematical model to describe it. He showed how viscosity affects fluids in pipes and channels. That's important for engineering and fluid dynamics, everything from blood flow to airplane wings.
So again, he's taking these abstract ideas and showing how they work in the real world.
Exactly. And his work with fluids wasn't just experiments. He also came up with theories to explain what he saw, like how sound waves travel through fluids. He was right that sound moves through compressions and rarefactions in the fluid.
Wow, he was figuring this out centuries before we had modern acoustics.
Incredible, isn't it? He even tried to calculate the speed of sound in air. He wasn't exactly right because he made some assumptions, but it's amazing he was even thinking about these things.
It's clear he wasn't afraid to explore. Did his interest in fluids go beyond things like water and air?
Definitely. He even thought about other fluids like the ether that people believed filled all of space. We know now that the ether doesn't exist, but it shows how open-minded Newton was. He wanted to explore everything, even the unknown.
So we've seen how Newton's work helped us understand planets, light, and fluids. Anything he didn't study.
You know, it's funny you should ask that. There's one more area we should talk about. It might surprise you Newton worked on heat and temperature.
Wait, heat and temperature? I never knew Newton did thermodynamics.
He didn't call it thermodynamics, but he was fascinated by heat. He did experiments to measure how fast things cool down. He had a theory about how heat moves through conduction.
Conduction, like when you touch a hot stove. Ouch.
Exactly. He even figured out a law to describe how fast heat conduction happens. We still use it today. He also looked at latent heat. That's the heat needed to change something from one state to another, like melting ice or boiling water.
So he was figuring out thermodynamics and heat transfer way before those fields existed.
Amazing, right? And as with everything else, Newton's work on heat wasn't just theoretical. He used it to solve problems, like making power furnaces and ovens. Even with heat, he wanted to use science to make life better.
It's incredible how many different things he was curious about. From planets to heat, it's like he wanted to understand everything about the universe.
That's what makes him so inspiring. His intelligence and his desire to use his knowledge to solve problems are incredible. It makes you wonder what he could have done with today's technology.
It's mind-blowing. But even without modern tools, he changed the world. His laws of motion and gravity are the basis of physics. His work on optics changed how we see light and color, and his work in math is still used today.
Exactly. His legacy isn't just about discoveries, it's about how he approached learning. He showed the importance of observation, experimentation, and using math. He believed science should be based on evidence, not just ideas.
He did things so differently. He said, hypotheses non fingo, which means I frame no hypotheses. He wouldn't make assumptions without evidence.
Right. He rejected the old way of thinking that relied on logic and authority. Newton wanted to test theories with experiments. He carefully documented everything, analyzed his data, and used math to describe the world.
His work became a model for how to do science the right way.
Exactly. And his influence went beyond his own research. He helped start the Royal Society, a group dedicated to learning through experiments and working together.
The Royal Society was a big part of the scientific revolution. They were all scientists who believed in using evidence just like Newton. That idea is at the heart of science today.
It is. Newton's legacy isn't just about what he discovered. It's about how he changed the way we learn about the world. The sources we're looking at show us his discoveries, his methods, his thoughts, and even his personality.
It's like we're in his lab watching one of the greatest minds at work.
And that's what makes this so interesting. It's not just about the past, it's about the future. Newton's work is still shaping how we see the world, and it's inspiring new scientists to keep exploring.
As we get to the end of our look at Newton's world, I feel amazed and curious. Amazed by all he accomplished, and curious about the power of the human mind.
You know, I'm also feeling humble.
Humble.
Yeah, because even after learning so much about Newton, there's still so much more to learn. His life and work are like a huge tapestry. We've only seen a small part of it.
It shows us that even with the smartest people, there's always more to learn, more to discover, more to appreciate. I'm also struck by how Newton's work was so scientific. But it also brings up these big philosophical and theological questions that we're still debating today.
It's interesting, isn't it? He saw the order and harmony of the universe as proof of a creator. He believed that science was showing us God's work. It makes us think about the nature of reality and our place in it.
Is the universe random or designed? Can science explain everything, or are there limits to what we can know? It's amazing that Newton's work is still making us think about these things.
Absolutely. His work goes beyond science. It makes us think about existence itself.
It really is amazing that hundreds of years later, we're still thinking about Newton's work and what it means. It's not just the science, it's these huge questions about why we're here and what the universe is all about.
Yeah, he wasn't just trying to figure out the physical world. He wanted to understand its deeper meaning. And by doing that, he pushed the limits of science and philosophy.
You know, it's like we've come full circle. We started wanting to see Newton as more than just the guy with the apple and gravity. And now we've looked at his brilliance, his methods, what he believed in, and even the philosophy of his work.
Quite a journey. We saw how his way of thinking led to those incredible discoveries that changed science.
And we saw how those discoveries are still important today. They make us ask new questions and explore new things.
Speaking of exploring, do you have a final thought for our listeners? Something for them to think about as they keep learning about Newton?
Yeah, what I keep coming back to is Newton's idea of a designed universe. He saw how ordered the cosmos is and thought it pointed to a creator. And he believed that his discoveries were showing God's work.
That's a powerful idea. It makes us think about science and faith, reason and belief. Can they work together? Or are they always going to be in conflict? Are they both part of how we understand the universe and our place in it?
It's a question that Newton thought about a lot. And we're still thinking about it today. I think it's fitting that our deep dive into Newton doesn't end with an answer, but with a challenge. To keep exploring, to keep asking questions, and to keep looking for meaning in the universe.
Well said. It reminds us that learning never ends. Even someone as brilliant as Newton only saw a part of what's out there.
And what a part he saw. So to our listeners, we encourage you to keep learning about this amazing man. There's so much to discover in his work and the questions he raised.
And who knows? Maybe you'll make your own amazing discoveries along the way.
That's a great thought. Well, that's the end of our deep dive into the world of Sir Isaac Newton. Thanks for joining us.